Yeah, so I'm guessing you probably saw this video on LinkedIn. So what you're basically seeing here is dash cam footage from a car driving in Spanish Town with a object detection model being run on it. As you can see, it's able to detect cars, it's able to detect people, and shows that those detections by drawing these bounding boxes around the objects that it detects, as well as it also shows of the probability associated with that object. Basically, how confident the model was that that particular detection was whatever it detected. All right, so basically, I'm just kind of going to walk you through the steps as to how I did something like this. And then hopefully from there, maybe you can think of some other project that may require you to do some sort of object detection, and you'd be able to do something like this on your own. So any video you can think of, you should be able to do something similar. All right, so let me just, I guess, walk through the steps. The first step is to come to here. All right, so with any machine learning model, we are going to require data. So the data that I use to train this model is the udacity um, self-driving dataset. The reason why I use this dataset is I was basically trying to see how those datasets would work on video that came from countries like Jamaica. If it would work as well. I mean, as you know, there's a lot of discussions as to the ethics concerning AI. Things like facial recognition, which uses people's facial images, and there's been a lot of hot debate as to whether there's some racial bias involved there because a lot of facial recognition systems don't tend to work so well with people of darker skin colors.
Yes.
So the aim here was to see if something similar presented itself with self-driving data sets. So let me see if I can find the data set. All right, so I downloaded the dataset from this link here, and I can put this link in this. You can find this link in the. I'll probably upload this video to YouTube, so you can probably find this link in the description.
Okay, no problem.
So yeah, so there's a short description of the dataset. The dataset may be stored in several formats. If it's a public dataset, sometimes it's stored in what we call JSON, maybe stored in XMLs, um, something called a TF record. It all depends. And depending on how the data set is stored, it will determine how you're going to extract that data. So if it's stored as, say, a TF record, then there's not much work you'd need to do on your part. Training the detection model is as simple as just passing that in. But if it's, say, stored in something like, say, a CSV file or XML, then you're going to have to do some extra work to actually convert that into a TF record so that the detection model is able to train. Um, yeah. So basically, they give a rundown of the different classes. So basically, different things that it can detect. So we have here car, pedestrian, traffic lights. Basically, some things you'd expect a self-driving car would be able to detect. So yeah, so the first thing you do is, of course, download the dataset. All right. So yeah, unfortunately, this dataset isn't stored as a TensorFlow TF record. If it was stored as a TensorFlow TF record, then we could have trained this object detection model just straight away. But the only available formats we have here are JSON, XML, TXT, and CSV. So for this one, we're just going to use the CSV option that's available right there.
Right.
All right, so we're gonna copy this code right here because we're going to need it. All right, so I'm just gonna leave that window open and then go to the next thing. All right, so what I'm going to use to do all of this training of my object detection model is something that we call Google Colab. The Google Colab, think of it like Google Docs for machine learning. So anybody can use it. So you click on the Google Colab link. Now, these guys called RoboFlow, they created what we call a notebook. Think of a notebook as basically just some segments of code that you can literally run and see the output of. So essentially what we're gonna do is to use that notebook that they actually provided, and then we're essentially just gonna plug in our data and then from there start training our model. So I'm gonna show you how that notebook looks. All right, so it looks like this. All right, so a lot of code has been provided essentially. So you can essentially just read along, follow along. So you don't really need to understand much of what's going on here. You just need to kind of fill in where your data set should go, and then you should be fine. So typically when you're creating your own custom object detection model, there's some added steps you would have to go through, which is essentially creating your own data set. For today, we're not going to go through that process. Probably in another video, we can go through how you create your own custom data set. But for now, we're going to use a public data set, the Udacity self-driving car data set. So yeah, which will make life a lot easier. All right, so the first thing we're gonna do, so to train this object detection model, we're gonna use TensorFlow. The TensorFlow is a deep learning, machine learning library. So remember, deep learning is all about using neural networks. So neural networks are very good at making predictions. And for this tutorial, we are making object detection predictions. All right, so the first thing we're gonna have to do is to clone our repository from GitHub, the TensorFlow repository that basically has all the object detection models. So using notebooks are pretty simple. You just click on the play button here, and it will execute the code in that particular cell. So I'm gonna click this here. And you just wait until it's finished. So if you press this refresh button over here, so here is basically all the folders that is being used by this notebook. If I refresh this here, you can see that there's now a folder called models. Because essentially it just downloaded this from GitHub. All right, so moving on. So before you even move on, you have to ensure that you are using a GPU runtime. All right. So you either can use the CPU or the GPU, or there's also something called a TPU. CPU is the slowest option. TPU is more Google specific, only works with TensorFlow. So in this case, we're going to use a more general purpose option, which is a GPU. All right, so we've run that cell. So basically what that did was, as I said, just downloads the Google TensorFlow object detection code. As I said, I'll provide the link to this notebook as well in the description, so you can actually use it yourself. All right, so the next cell here basically installs all the libraries, installs the object detection library as well, so you can use it. So here it's just doing a pip install, which is basically Python's package manager. So it's installing all the Python libraries here. As you can see, it navigates to the research folder inside the model folder that we just downloaded. Then it's going to install the object detection package using pip. So that will take some time. All right, so once you see some output here, that means that cell has completed its operation. So we can move on. So once you see this successfully installed, so you should be fine. So this is just doing some imports. You can run this cell as well. All right, so the next part here is basically we're just testing to see if everything is okay with TensorFlow. It's basically gonna try to build a TensorFlow model, and this is just doing a test to see if everything is running quite fine. We're just gonna run this cell right now. Some important outputs, as you can see here, where it says Tesla T4. This is the GPU that we're currently using, and this actually gives you an indication as to how much GPU memory is available. This is a very important number because this can affect how much images you can use for your batch size. I'll soon explain what I mean by batch size. All right, so it seems everything has been built fine. As you can see, we'll see a lot of okay. It seems everything is fine with that. All right. So let's run this cell here. Don't worry too much about what's going on in these cells here. We're not going to use it right now, but we might use it later. Essentially, what this does is, well, as I said, let us move on to the actual training of the data, of the object detection model. All right, so of course, the first step is with any sort of machine learning project is the data gathering. We've already gathered the data. It's this, right? So this is basically just a link to download the data. We're actually going to run this in a cell inside here, so we can download the data inside our directory right here. So we have the data already gathered, but it's still not enough format that TensorFlow needs to train its object detection model. The form that TensorFlow needs, or the format that TensorFlow requires, is something called a TF record. So after we download this data set, we're gonna have to figure out some way now to convert it to a TF record. All right, so as you can see here, we just use this command to download these files. What I'm gonna do is to copy this link here so that I can download it. I click the play button. All right, so let me refresh my directory. All right, so let's see what we'll have here. So it seems everything, oh, no, it seems everything is stored in this folder here. Export. Yeah. All right, so the important thing to realize is that in this folder, we have a bunch of images and we have this, a CSV file. The CSV file is the most important part because that is what we're going to use to generate our TF record. We're going to generate a TF record from our CSV file. So CSV file is basically just a file that has all the data. So it has, think of it like an Excel sheet where we have rows and columns. So in the headings, you probably have things like, the name of the image, the um, the actual thing that it detected, and where in the image it found that detection. So because it's a bounding box, it usually uses 4 numbers to determine where in the image it's detected, the X values and the Y values. So I have 2 X values and 2 Y values, X min, X max, Y min, Y max. With those 4 numbers, we can determine where in the image a detection occurred. So we're gonna have to convert this CSV file or create a TF record using this CSV file. Yeah. So I'm gonna have to find some code now to generate TF record. Luckily, we have some code on Github to do that. So I am going to copy this. And then I'm gonna try to explain what's happening here. All right. So let me add a cell after this. Copy all of this code. All right. So I do not think that this code was made for TensorFlow 2. I think this code was actually made for TensorFlow 1. But we're gonna try it out and to see if it still works. So give me a sec. All right, so usually with our data set, we have something that we call a label map file. So a label map file is basically, we have a number corresponding to each label. So let me show you an example of how a label map file looks like. See if I can find one here. Sorry, give me a sec. Let me just close this up. Here's one. Yes, so this is an example of a label map file. So as I said, each label or each class in our data set or each category has a number associated with it. So this is basically how TensorFlow will know which label to associate with the object detection. So it's basically what will happen is the object detection model will predict a number, and then it's gonna use the label map file to tell us what label that number is associated with. All right, so maybe it's a predicts a 1, then it's gonna look to the label map file to determine, hey, is this a car or what is it? All right, so first thing I'm gonna do is to upload this file because I'm going to need it eventually. All right. So we can actually open the file in here. Let's see here. All right. All right, so let's look at this file and let's see what's actually happening here. All right, so what is this doing? So if you look at here, it needs the path to the CSV file. You kind of give it what the output path is, so where it should output the TF records. Yeah. And the path to the images. All right. All right, so what's actually happening in here? So you don't have to worry too much about what's actually happening. But as I said, the CSV file is basically, think of it like an Excel file. Let me see if I can actually open it so you can see how it looks. But let me see if I can open it. But let me actually copy it using a command so you can see an example. So you can actually create a new cell and you can actually run terminal commands using the exclamation point. I can say cp /content /export /annotation .csv, and I am copying it to my current directory. So if I look here now, you can see I have my CSV file. It's too large to display. All right, I'm gonna download it so I can show you how it looks. So let me open that. All right, so this is an example of how the CSV file looks. So as I said, we have several columns here. So we have the file name, so the actual image. We have the width and height of the image. We have the category of the detection, and we have some numbers. So each of these corresponds to coordinate positions for the box. So I have xmin, ymin, xmax, ymax. So remember, y represents your vertical, x represents your horizontal. So xmax, ymax, well, yeah, xmax, ymax would correspond to like the top right-hand corner, I think, yeah. So yeah, each point, so remember you have a square, so each square has 4 points. A point can be described using two numbers, x and y position. So yeah, so that's what these numbers are for. So basically what the generate TF record is going to do is to go through the CSV file, look for the particular image, and then from that, get the detection, and then essentially generate a TF record so that we can do object detection. All right. All right, so let's kind of go through this. So as you can see here, for each row in our CSV file, it's going to get the xmin, xmax, ymin, ymax. And then from there, it's going to create the TF record from all of that stuff. Now, we need to edit one function, which is this. So essentially, remember I said each label is going to correspond to a number, and we can look back at our label map file to see what the numbers are. So we're gonna have to edit this. All right, so if it's a car, yeah, there's an easier way to do this. All right, so I'm gonna copy it. So essentially what I'm gonna do to make this function a lot easier is to just create a list. Instead of doing all those if else if else statements. I'm just going to create a list, and then I'm just basically going to return the position +1. So since the car is the first thing, that would be index 0. You add 1 and say you'd return 1, essentially. Almost out of time. Probably gonna have to create another link. All right, so I'm gonna separate these with commas. Comma, comma, comma. All right. So I have labels. So essentially, I'm just gonna say return labels. Yeah, labels.index row label. Yeah, so this will return the index position of the particular row label. And I'm gonna add 1. That should be that. All right, let me continue. Everything else there should be fine. Dun, dun. Okay. Let me see if this actually works. It probably won't. Let me see something. Okay. Let me remove this main here. All right, so I'm gonna delete this. All right, so the output path, we're just gonna say /content. Image directory is of course /export, well, /content /export. By the way, content is the name of the folder that we're currently in, if you're wondering. CSV input would be /content /export /annotation .csv. All right. Boom. Yeah, usually you just put this in like a Python file and then just run this command. But you know, since we're in a Jupyter notebook, we can just run the output here and see what happens. So let's try to run this. All right, so we get some errors here because it's saying that TensorFlow has no attribute Python_IO. So as I said, there's some new things in TensorFlow 2. So this is actually from TensorFlow 1. So you have to update some of this code to work with TensorFlow 2. So as you can see, it's renamed from Python.io to tf.io. So we're gonna call that tf.io. Let's run this again. So it's saying /content, not a directory. Put whatever you want the path to be, yeah, whatever you want the file to be called. So in this case, we want to be called train.record. Yeah, so let's try it again. All right, so what do I have here? So it's saying TensorFlow has no attribute G file. So again, we have to look up what the updated API is. So it's tf.io.g file. Let's come back here. Wait, don't worry about having to do all of this, looking up and Googling yourself. I'll actually provide the revised notebook with all of this in there already. But this actually shows you, some of the things you might have to go through as a machine learning engineer. Sometimes the API of some code is not up to date. So you're gonna just have to go and look to see if they're, or basically you're gonna have to update it yourself. That's what I'm saying. So it seems we don't have any more errors, so it seems to be working. Flag, oh, log. Yeah, I'm just comment. Oh. So what have we done so far? So basically, we got our data set. We installed the TensorFlow object detection API, and we were able to convert our CSV to a TF record. So the output of that is called train.record. So basically, this is our training data set. So TensorFlow can now use this to begin training. Everything from here is really just plug and play, really. So I have the name of the train record, so we can continue from here. All right, so two things we need. We need the name of the train record, what we're going to use to train with, and the label map file. Let me hide this. All right, so you don't have to concern yourself about the test because we're not going to be doing testing in that sense. So we can comment, or you can leave this. You don't have to edit it. It's not going to use it. Yeah, you can actually. All right, just leave it. But this now, you're going to remove this and replace it with. You can just click this copy path and put that here. And for the label map, do the same thing, copy path and put that here. All right, so let's persist. All right, so those variables have been set. As I said, don't worry about this one. The important thing is this one, the train record, and the label map file. All right, so let's continue. All right, so remember I said we're training an object detection model. Luckily, there are a lot of smart people at Google and other places that do research, create all of these new object detection models that are, accurate, more faster. So one example of that is what we call efficient depth. So it's a new type of object detection model that is supposed to be a lot faster with even more accuracy. There are a bunch of different object detection models. You probably have heard of something called YOLO before. We have something called SSD, single shot detection. We have something called ResNet. What you can do is come here, TensorFlow model zoo. Yeah, come right here, TensorFlow 2 detection model view. So this shows you all the different object detection models, the state-of-the-art object detection models. So the important numbers to look at here are the speed and the MAP value. So the MAP value just basically talks about the accuracy or describes the accuracy of the model. Speed is basically how fast. So, there are different trade-offs. Of course, if you're building something that you want to run in real time, like say, for example, on a self-driving car, you'd want something that can run very quickly because these things have to happen in real time. If you're more concerned about, say, accuracy, um, then maybe speed isn't so much of a concern. So you'd go with something that's more accurate, but probably slow. But of late, you have some new models that have both good speed and accuracy. The state of the art right now would be the efficient depth models um, that have a pretty good trade-off with speed and accuracy. You've probably heard of FASTA RCNN, or well, if you've never heard of it, that's one other popular object detection model that can be used as well. But for this tutorial, we're going to look at the efficient depth D0 model. So it has an MAP of 39, which is pretty good. Sorry, it has an MAP of 33.6. Not bad. Could be better. But the speed is very good. As you can see, 39 milliseconds. So it should run very quickly. So we could use this model for, say, real-time object detection. Or if you're really looking for really real-time, then something like a SSD mobile net. As you can see, the accuracy gets a real hit, looking at 20.2. Or you can maybe try this one, V1. But even that's probably V2. This one, yeah, but even the accuracy not very good for this. So D0 gives you a pretty good accuracy for the speed. So we're gonna use this one. So luckily this notebook already has the configuration for efficient D0. If you don't see a detection model that you probably want to use, the configuration for it in here, if you don't see it in here, you could basically just find it. Yeah, or you just need to know the model name. So what you do is basically just click on one of these. Let me see, copy link. So let's say, for example, you wanted to use this one, CenterNet, Hourglass. That's another object detection model that has good speed, the accuracy. So yeah, the important thing is this here. So I'm gonna copy this so I can show you how it would look. So from this, you can determine the configuration. So let me show you an example. All right, see, if you look here, right? Yeah. So this is a model, the pre-train, the name of the pre-train checkpoint. Basically, how these object detection models work is that, like as I said, the guys at Google, they would have trained this model from before with data set from, probably, a data set of animals or, people, stuff like that. The idea is something that we call transfer learning, where they would train the data set on like a bunch of different images, and the idea is that what it learns from that data set, it's supposed to be able to transfer some of that knowledge over to your new custom data set. So it should make training your training the model with your custom data set a whole lot easier because it wouldn't have to start exactly from scratch. Yeah, essentially, what you need is this: the name of the pre-trained checkpoint file, the pipeline file. Let me see if where you can find the thing there for that. Give me a sec. Yeah, I think you just basically just put .config after this, and that should be fine. And the model name would just be this. But yeah, for this tutorial, we're just gonna look at the efficient depth model. So we're gonna just use D0. The configuration is already there, so we don't have to worry about finding what these are. So we're gonna use efficient depth D0. So, as you go up with the numbers, D1, D2, it gets more accurate, but also it gets slow. We're going to use the fastest one, which also has which is also least accurate. But as I said, this is for a self-driving quote unquote car, so we need something that's pretty fast since we want to run it in real time. So yeah, so the important number to look here is the batch size. So here we have a batch size of 16. The higher you go in batch size, the more GPU memory it's going to take. All right, so you have to look out for that. So if your GPU doesn't have a whole lot of memory, then this batch size will be limited. Depending on some models, if the model is bigger, then this batch size might have to be even lower. Sometimes 4, 1 even. So yeah, so we try to keep it at a decent enough number. Some people use 32, some people use 16, 48, 128, some power of 2. But as I said, the higher you can go, the better. But you're always limited by the amount of GPU memory you have. So you can really go that's your bottleneck. You can really go as much as your GPU memory. All right, so we'll have the configuration here already, so we don't have to worry about that. So we just choose which model we're going to use. In this case, we're going to use D0. If you wanted to use D1, then you just change this to 1, D2, change that to 2, so on and so forth. So let's look at some other variables here. So num steps, this is the amount of steps it will train for. In this case, it says 40,000. Eval, don't worry so much about this. Basically, it's supposed to evaluate after this much steps. I don't think this notebook does any evaluation. Yeah, that's pretty much it. So run that now, and then run this. So this will download the actual model. So you just downloaded it, and now I'm going to download the config file as well. Yeah. All right, so let me run the cell as well. So it's basically this has a path to the checkpoint as well as the pipe. So remember I said the checkpoint is basically all the settings, save the settings for the model. So remember the model was trained on some data from beforehand. So they froze or basically saved those settings, and we're just basically loading back those settings. So when we're training on our new data set, we don't have to train from scratch and waste time. We train from their settings so that it trains a whole lot faster. So that's what we call transfer learning. All right, so run that cell. So this cell node, this basically just edits our config file with the path to our data set, all of that stuff. Look at this. So if I look at our config file, so some important things to look at: the batch size. In this case, it edits the config file and puts in the batch size. Things like a learning rate. Learning rate just describes how fast it learns. Yeah, the path, the lib path file, so it puts that in there as well. also the train record. All right, so let's move on. So load that. So essentially, when it's training, it's gonna store its output in this folder called training. So that's what was specified here with model directory. And here I'm basically gonna run this file. So this is a file that's gonna be used to train our actual models. Some important stuff needs a path to the pipeline file, which we just showed you a while ago. The model directory, which is just a folder that you're gonna store the output of the training to. The number of steps, which we defined earlier, number of eval steps. So I click play now, so everything should be ready for this thing to start training. So you should see a bunch of output you probably can't understand, that's fine. You just wait until you see some indication that it's training. So you might run into an issue where you run out of memory. Usually if this does not work, meaning it stops and it doesn't look like it's training, that's probably the issue, which just means you need to reduce the batch size or find a GPU with higher memory. Since this is a Google Colab, we're kind of limited with how much GPU you can use. Some important things to note with Google Colab, you get a limited time. So you need to make sure that you're on the window so that it doesn't kick you off, because it has to be sharing your GPU time with other people. But if you do get like there's something called Collab Pro that will allow you to actually get more time. So what I'm gonna do is allow this to train for um, a few steps. So I'll just show you how the training output should look, so you can know that it is training. And then from it, reaches a certain amount of steps, then I'll show you from there how you can export that train model to something that we can use to do detections with. So that's where actually we're gonna get a video, and then we're gonna use the object detection model to basically do object detection on each frame of the video. Remember, a video is really just a bunch of moving images. So essentially what we do is just loop through all the frames of that video, run the object detection model on each frame, and then produce a new video with the object detection basically on top of each frame. It takes a while for the training to begin, but you should see something popping up soon to indicate that it has begun. So it's doing a lot of stuff here, like loading stuff into memory, getting stuff ready, loading what we call the graph, the TensorFlow graph into memory, so that you can run all the TensorFlow operations. So the idea behind training is basically you have some ground truth, and the model is going to make a prediction. It's going to compare the prediction against the ground truth. Depending on how badly that prediction is, it's going to make some modification to its weights so that the next time around it can make a prediction that's closer to the ground truth. It does that until it becomes very good at predicting the ground truth. All right, so our model is actually training. So when you see something like this, like step 100, blah, 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 that means it's training. So some important numbers to see here, the time, this just tells you how long it takes for each step. So in this case, that's pretty long. Oh, well, it's a pretty high batch size, so 16. So yeah, the higher the batch size, bigger this number is actually. So this is the amount of seconds it takes for each step. So there's 16 images being used for each step. This is the amount of time it takes to process 16 images. And the loss value here we have 1.183. So essentially what you want to see is this value going as you go along. In the meantime, I'm gonna look for the the other notebook, which I'm going to use to do the detection on. All right, where are we? Yeah, I think this saves a checkpoint every 1,000 steps. So in the meantime, let me actually explain what's going to happen after this. So essentially what's happening here, it's going to create checkpoints. So basically, it's going to store its or save its settings periodically. So what's going to happen is when we stop this, it's going to use its latest settings. So one of these checkpoint files, the number indicates the order. So it's going to use the latest one to create what we call a the output, the model. It's going to be stored as a what we call a PB file. So we can use that model to do inferencing on the detection. So we'll run this, and then we should end up with something like this, a folder with the saved model, variables, stuff like that. But this is important piece, save model.pb. That's what we're going to use to run our detections with. So I think I already have a model stored, so I'm not gonna sit down here and wait on this to finish. I'm just gonna basically show you what should happen. Yeah, I do. It's right here. Yep, right here. Yeah, so you basically once this has finished training, all right, so once this has finished doing what it's doing, as I said, you would run this cell right here, which will produce a folder looking like this. So in that folder, we'll have the PB file. So essentially, this is a folder that you need to run the model detection. So I'm gonna download this folder. Okay. And then I'm actually going to upload it here. All right, so let me explain what's going on here. So this is notebook. Again, I'll put this in the description as well. Is the notebook that we're going to use to do some detection on video. All right, so of course, import TensorFlow as always. The important function inside all this here is this one. This. So this is the thing that allows you to see the visualization of the boxes on top of the images. So essentially what it does, let me show you. Yeah, so I'm gonna walk through the code. So the first thing we do is import something called Opencv. Opencv is a thing, it's an image processing library essentially. So we have a function here called video capture that can take in the input stream from a video file. So that's what this will end up being. And then essentially we can also write to a video file. So here we're saying we're going to write to a file called driving.avi, and we can specify the format. In this case, we're saying it's an MP4. We specify the frame rate as well as the size of the video. So it's a the resolution, 1280 by 720. So here we're saying while this stream is open, we're gonna read from the stream. So this is just gonna capture an image from the video. Then this is just gonna convert that image to what we call a tensor. So basically that's how TensorFlow accepts data. And then we're gonna run the detection model on that data. So that will come back with a bunch of detections. And then we pass those detections to this function here. So you pass the boxes, the position of the boxes, the classes, so the categories and the confidence scores. And then it will basically produce an image stored as this with the detections. So the writer that I created that's going to be used to create the video is basically I'm going to write that image that has the detections overlaid on top of it to the video file. Once that's done, I'm just basically going to release the input and the output streams, and then we should have a video file created with this name when we're done. All right, so let me actually stop this since, as I said, I already have I already have this file done. So things I need to upload. So I'm gonna upload the thing that I literally just downloaded. It's called saved model. But yeah, that's another thing too. Like if you don't stay on this window for too long, it will just delete all the files that you have in Collab. So that's another thing to look up. Again, ensure that you're using the GPU. So I'm gonna copy the path here. I'm gonna unzip this. All right, so we'll have this folder. So we're supposed to end up with a folder like this called saved model, the PB file here. I need to upload the label map file. driving. Again, I'll put the label map file in the description as well. So yeah, run this. So what this will do is basically read from the label map file. So it basically just create a dictionary with each category corresponding to a number. And then here we're simply loading the TensorFlow model. It's pretty simple to load the TensorFlow 2. Just say tf.save model.load and we'll pass in the path to the model. Essentially the folder. Click that. Should see a bunch of output. That TensorFlow is basically importing this model. It's loading the model into memory essentially. Yeah, don't worry about these warnings. They don't really mean anything. Or it shouldn't mean anything to you right now. All right, so as I said, well, first of all, we need a file. So let's upload a file that we're gonna run this thing on. So in the meantime, yeah, I've been thinking what we could do. I guess you could let me know if you think this is a good idea. Yeah, I mean, I have a bunch of ideas for different projects we could do. You know, I'm very interested in like self-driving, humanoid robotics, you know, swarm robotics, you know, basically all the cool stuff. So you know, we could do this like you know every Sunday where we just go through some possible projects. You know, we just do some live sort of coding sessions like this. The Patois bot is something that I really want to re-explore. Probably we can try that out for next week.
Yeah,
But
be a bit possible because actually looking to be a project similar to it.
oh, okay. Right. All right. So we have our video uploaded. So let's load it into the stream. Let's run. All right. So this might take some time. Yeah. So we have our output file here. So let's download it and see how it looks.